In this video lesson, we're going to look at subtractive color theory and how that relates to light and optics. So, question, what would you expect to see if all of the Roy G. Biv color spectrum was combined into one? What would that look like? So, our last lesson we learned about additive color theory. Now we're going to learn about subtractive color theory. So that says that if you take away different colors from white light, you can reliably make different colors. So this is the way we normally think of mixing colors. How do we do that? We do that using filters or colored transparent objects. So they only let some light through. So for RGB filters, only the color that matches the filter will pass through. For CMYK filters, so that's using cyan, magenta, yellow, and black, the color of light that is complementary to the filter will not pass through. So there's a FET animation where you can try that on color filters. So here's how it works. So primary colors. To get red, it would be white minus green minus blue. To get green, it would be white minus red minus blue. And to get blue, it would be white minus red minus green. Secondary colors. To get magenta, you would take white and subtract green from it. So again, white and subtract green, and you would get magenta. To get cyan, this one here. I'll just put my pointer on instead. So to get green, you would take, or cyan, you would take white. So here's white and subtract red. Red's right across, so you would get cyan. Yellow, you would have white minus blue and then yellow straight across. So tints and shades. White, you would use a clear filter, and black, you'd use an opaque filter. Or you can use pigments. So pigments are dyes or paints that absorb different colors. So for example, a red car absorbs green and blue and reflects red. So if we wanted to get green, you would add yellow and cyan to get green. If you want red, you would mix yellow and magenta, and that would give you red. And then to get blue, you would take cyan and magenta and mix them together, and you would get blue. So that's how you would add the pigments together. So some applications of subtractive color, that would be using paints, mixing colors in paints, clothing, food dyes, photography, newspapers and magazines use this, and we use it to reproduce the colors that light can combine to make. So again, some practice. So pretend that you're working on a magazine and you're preparing to print. What would you need to do to produce the bright red color of an apple, or the color of the afternoon sky, the green leaves of a tree, the deep blue of a dragonfly body, or the white of snow? So if we go back here, remember when we add these colors, it's reversed. So you're trying to find those colors, what two would combine to make the color that you're looking for. So for example, the bright red of an apple, the printer uses CMYK, subtractive color. So if I wanted red, I'd have to layer magenta and yellow together to get red. So you'll do the same for the rest of them, the color of the afternoon sky and so on.